Our last example in this section, before you get to do the exercises, is about a bacteria population. So we have a population of bacteria that's governed by a differential equation dp dt equal to 0.2 p, where t is measured in hours. Assuming that the starting population of the colony is 500 bacteria, what is the population of the colony after 2 hours? So we are given a differential equation dp dt equal to 0.2 p, and we are also given an initial condition. The initial condition is that the starting population is 500 bacteria. We can translate that into p of 0 is equal to 500. So now we have an initial value problem. We have a differential equation and we have an initial condition. We first solve the differential equation using separation of variables, and then we are finding the specific solution using our initial condition. So separation of variables, it always starts the same way. I'm multiplying by dt. So I have dp is equal to 0.2 p dt, and then I'm going to divide by p. So I have dp over p is equal to 0.2 dt. Integrating both sides, I have the integral of dp over p is equal to the integral of 0.2 dt. This looks similar to a differential equation we have seen before, our first example. On the left-hand side, when I integrate, I get the natural log of the absolute value of p, and on the right-hand side, I get 0.2 t plus c. Solving for p as we did before, the absolute value of p is e to the 0.2 t plus c. Dropping the absolute value, I have p is equal to some constant d times e to the 0.2 t, and this d again comes from the fact that I can take plus or minus e to the c. That is our arbitrary constant. So here we have the solution to our differential equation right there. Now I can solve for d subject to the initial condition p of 0 equal to 500, and so I have 500 is equal to d e to the 0.2 t, and t takes on value 0 because that's our starting point. So we have 500 is equal to just d. That is our initial population. So our overall solution then is, our specific solution, particular solution, is p of t is equal to 500 times e to the 0.2 t. They are asking us in this problem not just to find the solution, but also to use the solution to find the population of the colony after 2 hours. And since our solution gives us a population at any time, we can now find out that after 2 hours, the population is 500 times e to the 0.2 times 2. And when you evaluate that in your calculator, you get approximately 746 bacteria. So after 2 hours, our bacteria colony has grown to 746 bacteria.